Chapter 5 introduces one of, if not the most fundamental concept in finance, time value of money. This is such an important topic that the chapter is divided into 3 parts. In this Part A, we'll cover the basics of time value of money. In Part B, we'll cover annuities, and in Part C, we'll expand into related topics of rates of return and amortization. Time value of money problems are quantitative and can be solved in several ways. First, we have to understand the definitions. We'll look at the formulas as well as solving TVM problems with a financial calculator and in Excel. Present value is the value at time 0, today. When looking at a stream of cash flows over time, present value is the current value discounted at an appropriate rate. Future value is a more intuitively comfortable concept. This relates to the value at some point in the future of an investment made today. Under various circumstances, the interest rate can be called the discount rate, the cost of capital, the opportunity cost of capital, the required return. We'll use these terms as we move through the topics in this class and understand the different usages. Drawing a timeline to understand when cash flows occur can be helpful, especially when the setup is complicated. On a timeline, the ticks mark the end of the period, so the 1 marks the end of period 1. The default in finance is that cash flows occur at the end of a period. Time 0 is now, today. When representing cash flows on a timeline, we observe some rules. If a cash flow is coming into you, it's positive. Out from you is negative. So a loan is income to you, so it's positive. Depositing money in a savings account is an outflow from you, so it's negative. The abbreviation CF implies that the cash flows in different periods are not the same value. The abbreviation PMT means the cash flows in each period are the same amount. Here are some timeline examples. The upper one shows a lump sum, a single amount due as income, it's a positive cash flow, in 2 years. The lower line shows an ordinary annuity with a $100 income every year for 3 years. We'll be working more with uneven cash flow streams like this one, where the cash flows in each period are not the same. With uneven cash flows, drawing a timeline and placing the cash flows can be very helpful. TVM is where you begin to really need your financial calculator and Excel, so let's review the calculator basics a bit. This chapter primarily uses the TVM, or the gray keys, in the highlighted row. Remember, either PV or FV must be negative. You can't have income now and in the future. Also recall, interest rates are entered as a whole number, so 5% is 5. Data entered in calculator registers stays there unless overlaid or cleared, so it's safest to clear registers before starting a calculation. To clear the TVM keys, you can press second and clear TVM, or simply place a value in 4 of the 5 keys and solve for the 5th one. Also recall that setting your calculator to default to 4 decimal places. If you've not already done so, make the change now. Second, format, 4, enter, second, quit. We'll be working quite a bit with the calculator, but we'll cover the associated Excel functions as well. For each TVM key, there is an Excel function. You don't need to remember the exact name of the function nor the order of the parameters. Click on the FX icon and select the appropriate function. A window will appear with blanks for the needed parameters. We'll begin our study of TVM with future value since it's the more intuitively comfortable. This is the basic future value formula. Future value at a point in the future is equal to the present value times 1 plus the interest rate, quantity raised to the number of periods in the future. In a formula or in Excel, the interest rate is a decimal. If you remember the old future value tables, the values in those tables are the 1 plus I raised to the n. In your calculator, you can compute 1 plus I raised to the n using the y to the x key. To compute 1 plus 5% raised to the 3rd power, enter 1.05 y to the x 3 equals. Here's an example of compounding. What's the future value of $100 invested at 4% for 3 years? The timeline shows the value and what we're solving for. We can find this future value in several ways, step by step manually, using the financial calculator, and using Excel, and we'll look at all 3. Taking a step-by-step approach. In year 1, the $100 at 4% earns $4, so now you have $104. In year 2, the 104 at 4% owns $4.16, so you have 108.16. In year 3, the 108.16 at 4% earns $4.33, so we end up with 112.49. The general case, 100 times 1.04 raised to the third power is equal to 100 times 1.124864, 112.49. Solving the problem in the TI Business Analyst 2. N is equal to 3, IY is equal to 4. Present value is a minus 100. It's negative. It's an outflow. You invested the money. Payment is 0. Compute future value. The comparable Excel function is shown at the bottom. Consider the future value formula. For a given interest rate, the longer the period, the higher the future value, meaning the longer you leave your money invested, the more you have. As N increases, FV increases. The relationship between N and future value is direct. As one increases, the other increases. For a given time period N, the higher the interest rate, the greater the future value, meaning the higher the interest rate you can earn, the more money you have in the future. The relationship between interest rate and future value is direct. Now let's turn to present value. If finding a future value is compounding, finding a present value is called discounting. Present value discounts future values to times 0, now. Finding a present value answers the question, how much do I have to invest today to have some specific amount in the future? What is the current value of an amount to be received in the future? Why is a future value worth less today than its face value? 2 reasons. Opportunity cost. If I had the money today, I could invest it and have more than its face value in the future. The further out in the future, the more I could have earned. Risk and uncertainty. Bird in the hand is true. Money in my hand is certain. Money promised in the future is uncertain. The more uncertain, the more risk. Thus, it's worth less today. The discount rate used to calculate present value is a function of opportunity cost and risk. To find the present value equation, start with the future value formula and just solve for PV. This is the basic discounting formula, the opposite of compounding. With compounding, future value is greater than present value. With discounting, present value is less than future value. You divide the future value by 1 plus the interest rate raised to the power of the number of periods. Here's a present value example. What is the present value of $100 to be received in 3 years if the discount rate is 4%? Finding a present value is discounting. The timeline describes this question. Using the formula, present value is equal to future value divided by 1 plus I raised to the n. Present value is equal to $100 divided by 1.04 raised to the third power. We can solve this in the calculator using the y to the x and 1 over x keys. Enter 1.04 y to the x 3 equals 1 over x times 100. And you get the result, 8890. In your calculator, using the same technique we used for future value, enter 4 values and solve for the 5th. N is 3, IY is 4. Payment is 0. Future value is 100. Positive, it's an inflow. Compute present value. The comparable Excel function is also shown. Looking at the present value equation, for a given interest rate, the longer the period, the lower the present value. Meaning, the greater N, the larger the denominator, the smaller the result. The further in the future a cash flow will be received, the less it's worth today. The relationship between present value and N is indirect. As one increases, the other decreases. For a given time period, the higher the interest rate, the lower the present value. Meaning, the greater the interest rate, the larger the denominator, the smaller the result. The higher interest rate reflects greater opportunity cost and or higher risk about actually receiving the cash flow in the future, making it worth less today. The relationship between present value and I is indirect. As one increases, the other decreases. As a refresher, here's the basic present value equation. It has 4 parts, PV, FV, I, and N. In your calculator, enter any 3 plus a 0 in payment and solve for the 4th. And don't forget the sign convention. Inflows to you are positive. Outflows from you are negative. This video tutorial is posted in Blackboard. If we can solve for present value or future value, then we can solve for any of the other components as well. To solve for I, solve the equation for I. To solve this equation in the Texas Instruments, you can use both the y to the x and the 1 over x keys. Enter future value divided by present value y to the x, 1 divided by n equals -1. But solving for I in the calculator is much easier. As we did with present value and future value, enter 4 values and solve for I. Example, what interest rate would cause $100 to grow to $119.10 in 3 years? N is 3, present value minus 100, payment is 0, future value is $119.10, compute IY. Solving for n can follow the same pattern. We can solve the basic FV equation for n, but that gets a bit complicated. We can solve this in the TI using the LN key, but using the TVM keys is much easier. If sales grow at 10% a year, how long before sales double? IY is 10. Present value is a -1, payment's 0, future value is 2, compute n. While I certainly expect you'll use either a financial calculator or Excel to solve quantitative problems, this tutorial shows you how to solve TVM problems without using the TVM keys, not really by hand, but using other features of the calculator. The TVM by hand tutorial video is posted with this lesson, and I strongly recommend you watch it. Besides showing you alternate ways to solve TVM problems, it will also acquaint you with some useful keys and functions of the TIBA2+. This ends Part A of Chapter 5.